Hello everyone. In the previous class we discussed about the nomenclature of aromatic compounds. Okay, today we continue with the same. So this species already we have discussed. What are these? Phenyl, okay, phenyl, orthophenylene and orthotoluene. Next, benzyl, benzol and benzo. So benzyl means what now? If you remove hydrogen from CH3 group of toluene, from toluene molecule from CH3 group, if you remove one hydrogen, it is called benzyl. Suppose you take benzyl alcohol. Benzyl alcohol formula what now? Benzene ring bond CH2 bond OH. It is benzyl alcohol. If it is benzyl chloride, here Cl will come. So benzyl means what? C6H5 bond CH2 bond. C6H5 bond CH2 bond is called benzyl group here. This group is called benzyl group. So it is benzyl chloride. Okay. Next, if you take benzol. Suppose benzol chloride. That means here it will be Cl again Cl. Each chlorine has single bond here. Each chlorine is monovalent atom. So each chlorine forms one bond. So here CH with two bonds. C6H5 bond CH with two bonds. This is called benzol. So benzol chloride, meaning what? C6H5 CH Cl2 we say. C6H5 CHCl2. It is benzol chloride. Okay, next benzochloride. Suppose benzochloride. So benzochloride means what we say? Cl3 we take here. So here three bonds are there on the carbon here. So C6H5 bond CCl3. C6H5 bond CCl3 is called benzochloride. Benzochloride. So in this way, benzyl chloride, benzol chloride, benzochloride. So these are all things we should not confuse. Next, already we discussed that when two CH3 groups, when two methyl groups are present in benzene ring, that is called xylene. And here we start number one for this carbon, it will be number two. Okay, so here second position is called what? Ortho position. So it is second methyl group is on ortho position now. So it is called orthoxylene. And here first carbon one methyl, second carbon one methyl. So 1,2 dimethyl benzene is nothing but orthoxylene. Next, here if you start first carbon here, second and third carbon is having methyl. Third position is called meta position. At meta position, methyl group is attached here. So 1,3 dimethyl benzene. 1,3 dimethyl benzene is also called metaxylene. Metaxylene. And next here, first carbon, second, third carbon, and fourth carbon. Now fourth position is called para position. Here methyl group, second methyl group is at para position. So it is called what now? Paraxylene. Paraxylene or 1,4 dimethyl benzene. 1,4 dimethyl benzene. So dimethyl benzene is nothing but xylene. Remember. I check here in this example, a first carbon, second carbon, third carbon, fourth carbon, fifth carbon. It is sixth. Now, where the CH3 groups attached first carbon, third carbon, and fifth carbon. So 1, 3, 5. 1, 3, 5. Trimethyl benzene. Trimethyl benzene. It is also called mesitylene. Mesitylene. Mesitylene is called 1, 3, 5 trimethyl benzene. So trimethyl benzene is called mesitylene. Dimethyl benzene is called xylene. Okay, let's take the screenshot of this one. Next, hydroxy derivatives. Hydroxy derivatives of benzene. Hydroxy derivatives of what? Benzene. Suppose you take benzene with one hydroxy group. One hydroxy group is called phenol. It is called what now? Hydroxy benzene. What is it called? Phenol is called hydroxy benzene. Hydroxy benzene is called what? Phenol. Next one. Here, along with hydroxy group, one methyl group also is there. On the benzene nucleus, one OH group is there, one methyl group is there. So it is called cresol now. Cresol. Okay, now check it here. Now between OH and CH3, which is the principal functional group here, OH group. So wherever OH group is attached, that should be given first carbon. On the benzene nucleus, the first carbon is the carbon which has what? OH group. Okay, then numbering should be given anti-clockwise like this. So here second carbon should be given to the carbon on which methyl group is attached. So a 2-methyl is coming here, 2-methyl phenol. So this molecule is what now? This molecule is actually phenol molecule. In this phenol, at second carbon, what is there? Methyl is there. So 2-methyl phenol is nothing but orthocresol. Now here second position is called always ortho. From first carbon, the second position is also always called what? Ortho position. Ortho position. So ortho position is second position. So orthocresol. Otherwise, 2-methyl phenol. So what is generally cresol here? Methyl phenol. Methyl phenol is called cresol. Methyl phenol is called what now? Cresol. Cresol. If 2-methyl groups are there, xylene. If 2-methyl groups are there, xylene. One methyl group and one OH group present on the benzene ring is called cresol. Cresol. And one OH group on benzene ring is phenol. One CH3 on benzene ring is toluene. One methyl group on benzene ring is what? Toluene. Like that. Next, here you check here. In this case now here, CH2OH is there. CH2OH. OH is what principal functional group here. Okay. So here in this case, what is this group called? Tell me. Phenyl ring bond CH2. Phenyl bond CH2. C6H5 bond CH2 is called benzyl or benzol. Benzyl group, this one. So this benzyl group is having what? OH. Benzyl alcohol. Benzyl alcohol is this one here. C6H5. How to write this one? C6H5 bond CH2 bond OH. This is called what now here? Benzyl group here. Benzyl group. So benzyl alcohol. This one. So benzyl alcohol and orthocresol phenol. These are hydroxy derivatives of benzene compound. Benzene and benzene derivatives. Let's take the screenshot of this one. Next one. Here, two OH groups on benzene ring. Benzene nucleus bears how many OH groups, how many hydroxy groups? Two hydroxy groups. That's why it is called here catechol. Catechol. Catechol is what now here? Benzene with two hydroxy groups. The two hydroxy groups on benzene ring is what now? Catechol. In this case now here, first carbon, if you take this one, it will be second carbon. If you take first carbon here, it will be second carbon. Anyhow, we can take first, second or first, second. Anyhow, 1,2 dihydroxy we are getting. 1,2 dihydroxy benzene, which is called catechol. Okay, dihydroxy benzene. Next one here, OH group at first position. If you take here, it will be second carbon. It will be third carbon. Now third carbon bears what? OH group. Okay, so it is called what? 1,3 dihydroxy benzene. 1,3 dihydroxy benzene is commonly known as resorcinol. Resorcinol. I told you, in organic compounds, in aromatic compounds, resor means what? Common name as well as IUPAC name will be same. Yeah, resorcinol can be used as IUPAC as well as common. Another name also we use what now here? 1,3 dihydroxy benzene. It is called resorcinol. Yeah, 1,2 dihydroxy benzene is catechol. 1,3 dihydroxy benzene is called resorcinol. And here check it. Here first carbon and fourth carbon. Now 1,4 dihydroxy benzene. 1,4 dihydroxy benzene. Like this, different hydroxy derivatives of benzene we take. Here, how many hydroxy groups in these? Two hydroxy groups. Okay. Next. Now, between two phenyl rings, what is there here? Bond O bond is there. Bond O bond here. So generally, bond O bond is ether, na? Bond O bond is what? Generally indicating about ether group here. Bond O bond. So in this case now here, one ring will be taken as parent. Suppose this ring I am taking as parent. This is benzene nucleus. It is what now here? Benzene. This is parent, which is benzene here. And the other ring, other benzene ring with oxygen is called what here? Phenoxy group. What is phenoxy? Phenyl C6H5 and O. Phenyl and oxy. That's why it is called phenoxy. So this is phenoxy group here, the remaining part. The phenoxy group is attached to what? Benzene. Okay. So benzene, to the benzene ring, what is attached here? Which group is attached to phenoxy? Why it is called phenoxy group? This one. Why it is called phenoxy? Phenyl and oxy. Phenoxy. So phenoxybenzene. The Iupac name of this compound is what? Phenoxybenzene. It is also called phenitol. Phenitol. So phenitol or phenoxybenzene. Phenoxy. In this only name it take. PHEN. PHEN. Phenitol. Phenoxybenzene is called what? Phenitol. Okay. So these all names, if you write, it will be easy. That means you will feel strange in the beginning when you learn for the first time. Slowly, everything will be familiar to you. Means when you write repeatedly, it will be recorded in the brain. So it's about phenitol. Phenitol, okay? Next, here aldehydes and ketones. Means what now here? In the nucleus of benzene, they are called nuclear substituted, meaning what? On the nucleus of benzene. On the nucleus of benzene, generally here what will be there? C bond H will be there now. In place of H, what is there now here? CHO is there. Means on the benzene nucleus, one hydrogen is replaced by CHO here. The CHO group is called aldehyde. And C double bond O bond, CO bond is called ketone. So ketone group and aldehyde group are substituted on the nucleus of benzene. That's why they are called nuclear substituted compounds. Nuclear substituted compounds, aldehydes and ketones. Now check it here. So this what here? This compound has what now? Aldehyde group on benzene nucleus. So it is called benz aldehyde. Benz aldehyde. Benzaldehyde. Other name what I said? Benzene carbaldehyde. Benzene carbaldehyde we can say. Otherwise benzaldehyde we can say. Both are same. So it is benzene carbaldehyde or benzaldehyde. And next one, check it here. Here benzene ring means phenyl. This ring is what? Phenyl. And here bond CO bond is ketone. Bond CO bond is what? Ketone group here. Ketone. And CH3 is what? Methyl. So ketone generally how to write now? Bond CO bond na. So to one side of the CO, what is there now? Phenyl group is there. The other side, what is there? CH3 methyl is there. That's what we say commonly: methyl, phenyl, ketone. Methyl one side, phenyl one side. So methyl, phenyl, ketone. Methyl first letter is what? M. And phenyl first letter is what? P. That's why what is taken first? M. Methyl is taken first. Means we have to write first methyl, then only phenyl. So methyl, phenyl, ketone. Okay, that is acetophenone. What is the name of this? Acetophenone. Acetophenone. Okay, so this group, what I told you, acetyl group I told now. Acid. Acid means what generally? CH3. Acetic acid. Acid aldehyde. Acetaldehyde means CH3 CHO. Acetic acid means CH3 COOH. Acid means CH3 methyl. Okay, and this is phenyl. Phenyl. In this phen indicates what? Phenyl. Acid indicates what? CH3. ONE indicates what? ONE indicates what? Ketone. So ONE is what now here? Ketone. Like this, what here? Acid, phenone, acetophenone. Okay, so is the Iupac name. So commonly what we say? Methyl phenyl ketone. Methyl phenyl ketone or acetophenone. Is that clear, ma? Let's take the screenshot of this. And this group is what now here? Phenyl. This ring is what? Phenyl. So here phen and here acid. In this case, acid we have taken. Okay. Next now. Here between the two benzene rings, what is there? Ketone group is there. Bond CO bond is there. What is there? Bond CO bond. In this case now here, we say this is one phenyl group on one side of ketone. The other side of ketone group, what is there? Phenyl there. How many phenyl? Totally two phenyl. So diphenyl ketone. Previously, what we said, methyl phenyl ketone. Now it is diphenyl ketone. And also we say here benzophenone. Benzophenone. A phenyl and one. Phenyl and one. Phenyl and one. That's why it is phenone. So benzophenone we say. So benzophenone or diphenyl ketone. Benzophenone, otherwise diphenyl ketone we say the structure. Next, carboxylic acid. This means nuclear substituted, meaning what? Here, if COOH group is substituted on the benzene nucleus, it is called nuclear substituted compound. Means in benzene molecule, the hydrogen atom is replaced by COOH functional group. So it is called what here? Benzoic acid. Benzoic acid. Other name, what I said? Benzene carboxylic acid. What do you say? Benzene carboxylic acid. So benzene carboxylic acid or benzoic acid. Now in this case now, here COOH group is attached and also methyl is attached. Methyl is attached. Okay, so generally benzene ring plus COOH is called benzoic acid. Benzoic acid. Benzene plus only CH3 is called toluene. So together they have given name what now? Tolic acid. What is given? Tolic acid. Tolic acid, orthotolic acid. Again, here number 1 will be given to COOH carbon and to CH3 carbon we give number 2. This number 2 position is called what? Toluene, ortho position. Ortho position. So what is orthotolic acid? Tolic acid contains which substituents on benzene nucleus? COOH group and CH3 alkyl substituent. These two will be present on benzene nucleus. It is called orthotolic acid. Okay, toluene and ic acid, benzoic acid. Together, what? Tolic acid they give name. Next, here you see COOH group is there, hydroxy group is there. Between COOH and hydroxy, which is priority group? COOH is priority functional group. That is senior functional group. OH is less priority. That's why number 1 carbon is this carbon, to which COOH is attached. And number 2 carbon, this one, to which OH is attached. So 2-hydroxy we have to say. For this OH, we should use only hydroxy. We should not take OL. For the COOH, secondary suffix name, that is oic acid must be used here. So actual name is what now? Benzoic acid. Benzoic acid is parent compound. In this benzoic acid, hydrogen atom is replaced by OH group. At which carbon? Second carbon. On the second carbon, hydrogen atom is replaced by OH. That's a 2-hydroxy benzoic acid. This 2-hydroxy benzoic acid is also called ortho-salicylic acid. Second position is what here? Ortho position. That's why it is what now? Ortho-salicylic acid. Salicylic acid. So salicylic acid contains what? COOH and OH group on. COOH group and OH group. Both will be present on what? Benzene nucleus. It is called salicylic acid. Ortho-salicylic acid. Now also we have salicyl aldehyde. Remember, salicyl aldehyde, benzene ring, benzene nucleus with CHO. Okay, and OH. It is what now here? First carbon and second carbon. Okay, so it is what now here? 2-hydroxy benzaldehyde. 2-hydroxy benzaldehyde is called what now? Salicyl aldehyde. So salicyl aldehyde means what? Benzene nucleus with CHO group on it and OH group on it. So the first position is given to the carbon at which CHO is attached, and second position to the carbon with the OH group. So 2-hydroxy benzaldehyde. 2-hydroxy benzaldehyde is also called what? Salicylic or salicyl aldehyde. Salicylic acid means this one. Salicyl aldehyde means this one. These two names remember. Okay. Where we have come across these names, do you remember? In chemical bonding lesson, we discussed about this. Salicylic acid and salicyl aldehyde. Suppose if you take here CH like this. Here C double bond O and single bond H. It is CHO. aldehyde group, right? Next here, bond OH is there, bond OH. Now, between oxygen and hydrogen, there will be dotted lines. Dotted lines indicate what here? Hydrogen bonding. So this hydrogen bonding is between oxygen atom of this molecule, hydrogen atom of the same molecule. This OH group hydrogen and CHO group oxygen. Between these two, what will be there here? The hydrogen bonding is there here. The weak attractive force is there. So hydrogen bonding is generally between hydrogen atom versus more electronegative atoms like fluorine, oxygen, and nitrogen. With fluorine, oxygen, and nitrogen, the hydrogen can form what? Hydrogen bonding. So here with oxygen of CHO group, this hydrogen of OH group forms what? Hydrogen bonding. This is called intramolecular hydrogen bonding. What is called? Intra. So intramolecular hydrogen bonding. So this intramolecular hydrogen bonding is seen in which molecules? Salicyl aldehyde molecule and also salicylic acid. So here also between C double bond O and H, between oxygen of CO and hydrogen of OH, between oxygen atom of CO group and hydrogen atom of OH group, there will be weak attractive force called hydrogen bonding. This is within the same molecule now. Within the same molecule, hydrogen bonding is there here. So it is called what now? Intra. Intra means within. Intra meaning what? Within. So intramolecular hydrogen bonding is seen in salicyl aldehyde and salicylic acid. Salicyl aldehyde is nothing but 2-hydroxy benzaldehyde. 2-hydroxy benzaldehyde. Salicylic acid is what? 2-hydroxy benzoic acid. Is that clear, ma? Let's take the screenshot of this. Now see, some specific rules for IUPAC nomenclature. Some of these already we discussed. Now here in this compound now, suppose here, this is what now COOH carbon containing functional group here. And the other end, what is there now here? The carbon containing group with oxygen. It is what now carbon containing functional group with oxygen. When one end is what COOH carbon containing functional group, which is called chain terminating group, and the other end is also chain terminating carbon containing group which contains oxygen. If this chain terminating group at this other end has oxygen, then we have to give numbering to this carbon. We have to give numbering to this carbon. That's why a number one we start from COOH, because COOH group is senior than what? This CHO aldehyde. That's why number one we started to this carbon, second carbon, and third carbon this one. First carbon, second carbon, third carbon. Now 3 position should be given to this carbon because this carbon is having what? Oxygen. That's why we should give name. Now here, and also instead of formyl, here for this we are not using here, neither formyl, neither what we say, neither otherwise we take like this here. We don't use what now here, ALR we should not use it. ALR is not used. What we have to use for this here? Formyl we have to use. Formyl. So ALR we should not use here. Formyl should be used. Formyl is called what? Secondary prefix. Secondary prefix should be used here. ALR is actually what? Secondary suffix name. But we have to say only 3 formyl here. 3 formyl. Numbering is given a 3. So 3 carbon atoms means propane. Propanoic acid is parent compound here. In this propanoic acid, third position is with what now? Formyl. The same thing what I said here. If this carbon in CHO, CO is there actually. CO. The third carbon is CO carbon. Carbonyl carbon. Here this C double bond O is there like ketone. Like ketone, C double bond O is there now. So because of this, in some books it will be given 3-oxo will be given. The same name, 3-formyl old. 3-formyl is old name actually. Now modern concept what we have to take here, instead of 3-formyl, we should use the what now? 3-oxo. 3-oxo propanoic acid. 3-oxo we have to say. Here for though it is CHO, we should not use formyl actually. A C double bond O oxygen is there now to carbon. So like ketone, whatever the oxo for ketone we use, the same thing we have to mention here. 3-oxo we have to say actually. 3-oxopropanoic acid. Propanoic acid. But in olden days, what used here? 3-formyl we were using. Now we are using 3-oxo. So 3-oxo should be taken. Modern concept. Account IUPAC recommendations. Is that clear, ma? Both are same here. I'm erasing now. Okay. Let's take the screenshot of this. Yeah. So now I'm taking here. See here. Now the same structure I'm taking like this. COOH bond CH2 bond CN. I'm taking, suppose. Here, one end is starting with what? COOH, right? Here, this is first carbon, and it is second carbon. Now, this CN is what now? Cyanide group here. What is it? Cyanide group here. Is it chain terminating group or not? Yes, it is chain terminating group. But is it containing oxygen on it? No. This CN group is chain terminating carbon containing group only, but without oxygen here. When oxygen is not there with this carbon should not be given numbering. This carbon should not be given numbering as there is no oxygen with it. So numbering should be stopped here only. So up to this only numbering should be given. It is parent chain it is. So in the parent chain, how many carbon atoms there? 2 only there. So we have to say ith. What we have to say? Ith. So 2 carbons, ith we have to say. Then on second carbon, which group is there now? This one, cyano. So 2-cyanoethanoic acid. What is the name? 2-cyanoethanoic acid. What is the name of this? Tell me. 2-cyanoethanoic acid. Here, eth only we have to take root word. That means what? 2 carbon atoms only should be given. This carbon without oxygen should not be given numbering. Is that clear, ma? So it is 2-cyanoethanoic acid. So this concept should be understood. It is special rules, some specific rules for IUPAC nomenclature. Okay. Next. Now in this case, you see here, one side what is the cyanide is there here. Again, cyanide is there. 2 ends with the cyanide. Cyanide. With how many carbon atoms? 1, 2, 3, 4, 5, 6 carbons there. Here, this is the branch, which is neither methyl nor cyano. Only cyano is not there here. Only methyl is not there. Actually, bond CH3 is called what? Methyl. In this methyl, hydrogen is replaced by cyanide. In this methyl group, hydrogen is replaced by what? Cyanide. So it is called what now? Cyanomethyl. It is methyl here. And this is called what now here? Cyanomethyl. Cyanomethyl group it is. This cyanomethyl group is on which position? Third carbon. And is the cyanomethyl simple substituent or complex substituent? It is complex substituent, remember. Complex substituent. Why? Substituted substituent.